Hello children, how are you all? Hope so you are doing good. Welcome to one short session on geometric progression, class 10 ICSE. Before we continue with the concept, I request all of you to subscribe my channel, that is Ignite Math ARP, if you have not yet subscribed. So I have observed children, many of you view the channel and view the videos but forget to subscribe. Please do not do that. Subscribe first, then watch later. So now let me start with the concept geometric progression. So what is geometric progression? So I will take a sequence over here. Let me write some numbers over here. So I'll just write it as 2, 6, 18, 54. If you observe clearly, the first term, that is T1, what I call, is multiplied by certain constant number 3 over here, and this 6 is multiplied by 3 to get the next term, and 18 is again multiplied by 3 to get the next term, and so on. So here 2 is called as T1 and this 6 is called as T2, that is 18 is called as term number 3 and 54 is called as term number 4. So in a sequence, whenever a number is multiplied with certain constant number to get the next number, and again the second number is multiplied with same number, same constant number to get the next number, and if the sequence continues like that, so such kind of progression, such kind of sequences, we call it as a geometric progression, in short GP. It is not necessary that the second term is always obtained by multiplying children. It can happen by dividing also. Example, I'll just take one number over here. See, 20 is divided by 2, right? So it is divided by 2 to get 10. 10 is divided by 2 to get 5. Then 5 is again divided by 2 to get 2.5 and so on, right? So either you are multiplying the term to get the next term, or you are dividing a term by constant number to get the next term. In such kind of progressions, we call it as a geometric progression. Clear children? And this constant number which is obtained by dividing second number by first number. Okay, so it is 6 by 2, it is 3 in this case, and T3 by T2 if I do, that is 18 divided by 6, again it is 3, though obviously this number will be constant and it is called as a common ratio. It is called as common ratio. Keep in mind, which is denoted by the letter R. So now, how can I find out the 8th term of this GP? How can I find out 20th term of this GP? How can I find out 50th term of this GP? So I cannot keep on writing like this till the 50 terms. So I need to have a formula to find out the nth term of the GP, just like how actually we found out in case of AP. So let me derive the formula over here. So I'll just take this as a reference GP, whatever I have written over here. So 2, 6, 18 and 54 I have written. See, the first term, which is also called as A, right? Second term, look at this very carefully. When I multiply this A with 3, I'll get the second term. When I multiply A with the 3 square, okay, I will get 18. When I multiply this A with 3 cube, I'll get 54. So means what? I can rewrite this one as 2, right? So 2 into 3, and over here 2 into 3 square, and this is 2 into 3 cube. Clear children? So over here I'll rewrite this again as 2. Then over here I can write this one as 2 into 3 to the power of 2 minus 1. So 3 to the power of 1 over here, I'll just write it as 2 minus 1. This again can be written as 2 into 3 to the power of 3 minus 1. Yes or no children? 2 can be written as 3 minus 1. So over here, this can be written as 2 into 3 to the power of 4 minus 1. See, fourth term, this is our fourth term, so I have written 4 minus 1. This is our third term, so I have written it as 3 minus 1. So this is our second term, so I have written it as 2 minus 1. So generally I can write this one as a, then a into r to the power of 2 minus 1. Why I am writing 3 as r? Here we have found out r is equal to 3. Clear? So here a into r to the power of 3 minus 1. Here a into r to the power of 4 minus 1. If it is fourth term, 4 minus 1. If it is second term, 2 minus 1. If it is third term, 3 minus 1. A into r to the power of 3 minus 1. So similarly, if I want to find out the nth term, then it would be a into r to the power of n minus 1. So I can say the nth term of the GP is a into r to the power of n minus 1. So this formula we use to find out the nth term of the GP. Clear? Or last term of the GP. Clear, children? Right. So you must know that here n should be a natural number. Okay. A can be integer. Okay. R can be integer. Tn can be integer. But n should always be a natural number. Okay. In fact, R, A, Tn, they can be rational also, in the sense they can be decimal, fractions, whatever, but no compromise with n. N should always be a natural number. Clear, children? This is a very simple formula. You need to remember this. Now, let me take some of the examples on the same concept. Find which of the following sequences form a GP. So they have given you some sequences over here. I need to check whether they form GP or not. Okay, let me take the first one over here. 8, 24, 72, 216. It continues like that. So now here this one is T1 and this is T2, this is T3 and this is term number 4. So what I do here, I do T2 divided by T1. I'll find out the ratio between T2 and T1. 24 by 8, I will get it as 3. Then I'll find out T3 by T2. So 72 by 24, I'll get it as 3. Later, I can find out 216 by 72. Then also I'll get it as 3. So I can say since the common ratio R is same implies 8, 24, 72, so on forms a geometric progression. That is my conclusion. Clear, children? So common ratios should be same always, keep in mind. Now let me take the second example. Look at the second sequence over here. 1 by 8, 1 by 24, 1 by 72, 1 by 216 is given to you. I need to check whether it forms a GP or not. So here again this is T1, this is T2, this is T3 and this is term number 4. Now I'll find out the common ratio R, that is T2 by T1, that is equal to 1 by 24 divided by 1 by 8. So that is going to be 1 by 24 into 8 by 1. So that is going to be 1 by 3. So again find out the common ratio. This time I'll take T3 by T2. So that is 1 by 72 divided by 1 by 24. So that is equal to 1 by 72 multiplied by 24 by 1. So that is equal to 1 by 3 again. See, again I am getting R constant over here. You can take one more. R is equal to, this time I will do it like T4 divided by T3. So 1 by 216 divided by 1 by 72. So 1 by 216 multiplied by 72 by 1. So I get it as 1 by 3. So what's my conclusion here? Since the common ratio R is constant, it is same, I can say 1 by 8, 1 by 24, 1 by 72, so on forms a GP. Forms a GP. Clear, children? It is one of the property, in fact. because in the first case we checked 8, 24, 72 and 216 is a GP. Reciprocal of a GP is also a GP. See, if you observe clearly here, it is 1 by 8, 1 by 24, 1 by 72 and 1 by 216. That should also form a GP. About the properties we can discuss later. Now let me continue solving some of the examples over here. Find the ninth term of the series. First of all, you need to confirm whether it forms a GP or not, whether it is GP or AP or it is not at all any progression. You need to come to conclusion, right? Then you can go ahead with finding the ninth term using the formula, because here they have given series, they have not given it's a GP. Now I'll find out the common ratio. Common ratio is equal to T2 by T1, that is 4 by 1 is equal to 4. Common ratio is equal to T4 by T3, that is nothing but 64 by 16 is equal to 4. So therefore I can say 1, 4, 16, 64 is a GP. It is a GP. Now you are asked to find out the ninth term of the series. So we know that Tn is equal to A into R to the power of n minus 1. So ninth term, in the sense T9 is equal to A. What is A here, children? A is equal to 1 because first term is 1. So 1 into what is R? You have found out the R as 4. 4 to the power of which term I am finding out? Ninth term I am finding out. 9 minus 1. Clear, children? So I am finding out 9 minus 1. So now my job is to find out the answer. 1 into 4 to the power of 8. So 4 to the power of 8 is going to be 65,536. So this is going to be my ninth term of the given GP. Clear, children? Okay, let me take one more example over here. Find the nth term of the series. So again I need to confirm whether it is a GP or not. So R is equal to T2 by T1. I need to find out the ratio between the successive terms. So 2 by 1 is equal to 2. R is equal to T4 by T3. So that is 8 by 4 is equal to 2. So I can say that 1, 2, 4, 8 is a geometric progression. I'm supposed to find out the nth term. Okay, so now Tn is equal to A into R to the power of n minus 1. So what is A here? A is nothing but the first term. So I don't know what is n. That term only is to be found out over here. So A I am replacing it by 1 into R I am going to replace it by 2. Right? Substitute R by 2 because the common ratio is 2. Then n minus 1. So that is nothing but the nth term of the given GP is 2 to the power of n minus 1. So this itself is going to be the answer, children. Suppose if you are finding out the fourth term of the GP here. Okay, this is not necessary. I'm just showing you an example. Suppose if you are finding out fourth term of the GP, then 2 to the power of 4 minus 1, that is nothing but 2 to the power of 3, that is going to be 8th term. See, you are just substituting n by 4 to find out the fourth term. So our fourth term in the given GP is 8 itself. Clear, children? So you need to put the answer in terms of n itself. Don't write anything else over here. Now let me take the next question. The next question is find the GP whose first term is 64. See, children, here they are giving you first term is 64 in the sense A is equal to 64. Clear? And the next term is 32. Next term is 32 in the sense what a second term T2 is equal to 32. Correct, children? So now T2 means what? It is A into R to the power of 2 minus 1 is equal to 32. So A into R is equal to 32. So we know what is A. So 64 into R is equal to 32. So I can write R is equal to 32 by 64. Therefore, R is equal to 1 by 2. This is the common ratio. And I know the first term of the GP. What you're asked to find out? You're asked to find out the GP. So you must know the general form of GP. So general form of GP as shown already. It is given by A, AR, AR square, AR cube, so on. Correct. So I'm supposed to find out GP. So A, I know it as 64. I'll just keep it as 64. Then 64 into 1 by 2 because R is 1 by 2. Then 64 into 1 by 2 the whole square. Then 64 into 1 by 2 the whole cube, so on. At least 3 terms to be found out. So now I can write the first term is 64, second term is 32, then 64 into 1 by 4. So that is 16, then 64 into 1 by 8. It will be like 8. So this is nothing but the required GP. Okay, this is the required GP. This kind of questions can be asked for 2 marks, children, or it can be asked in multiple choice also. Now let us see the next question. Next question says the fifth term of GP is 81. So fifth term in the sense T5 is equal to 81. Fifth term can be written as A into R to the power of 5 minus 1 is equal to 81. That is nothing but A R to the power of 4 is equal to 81. I'm just calling this as equation 1. Later, its second term is 24. So second term is 24. So second term is what? A into R 2 minus 1 is equal to 24. So I can say this is A R is equal to 24. Clear, children? I just call this as equation 2. So now what I do? Now I can do equation 1 divided by equation 2. When I do equation 1 divided by equation 2, then I would get this one as AR to the power of 4 by AR is equal to 81 divided by 24. Clear, children? So A will get cancelled. 1R and 1R will get cancelled over there. So I'll be left with the R cube is equal to 81 by 24. So this can be still simplified as look at this. So 24, 3 8s are 3 27s are. So R cube is equal to 27 by 8 I can write. So R is equal to cube root of 27 by 8. So R is equal to 3 by 2. So now I got to know what is R. So your question is to find the geometric progression. So to find out the geometric progression, I must know what is R as well as I must know what is A. So my task is to find out the A. So next what I do, substitute R in any one of the equations, whichever is easy you feel. So in equation 2 I do. So now equation 2 is AR is equal to 24. I have already found out R. So A into 3 by 2 is equal to 24. I would get A is equal to 24 into 2 by 3. So I would write A is equal to 3 ones are 3 8s are. So A is equal to 16. So now I can write required GP is A, AR square, so on. So what is A, children? So A I have got it as 16. So I can write this one as 16. Then 16 into R. So what is R? R I have found out it as a 3 by 2. So 16 into 3 by 2. Then 16 into 3 by 2 the whole square. Clear, children? So now I can write this one as 16 and 2 ones are 2 8s are. So 8 into 3 is 24. So over here, if you get confused to write it directly, you can write one more step over here, no issues. Okay, 3 square is 9, 2 square is 4. So later I can write GP as 16, then 24, then 4 ones are 4 4s are. So 4 into 9 is 36. So this is our required GP. Clear, children? Okay. Now let us see the next question, children. In the next question, find the geometric progression with the fourth term 54. So I am aware what is fourth term. P4 is equal to 54. 54 can be written as AR to the power of 4 minus 1 is equal to 54. That means what? AR cube is equal to 54. I can call it as equation 1. So later it is given to you that the seventh term is 1457. Seventh term is equal to 1457. Okay, I mean 58. Right. So seventh term can be written as A into R to the power of 7 minus 1 is equal to 1458. So that is AR to the power of 6 is equal to 1458. I can call this as equation 2. So next what I am going to do, I am going to divide equation 2 by equation 1. Equation 2 is AR to the power of 6 by AR to the power of 3 is equal to 1458 divided by 54. Clear, children? So now I'll be cancelling this A and A, then I'll be left with R cube is equal to 1458 by 57 give you 27. Okay, 1458 divided by 54 gives you 27. So R is equal to cube root of 27. R is equal to 3 I get. So what I'm supposed to find out now? I'm supposed to find out A, because you're asked to find out the geometric progression. To find out the geometric progression, I must require R as well as A. Now what I do? Substitute R in equation either 1 or 2, whichever you find easy. Equation 1. So now I can write A into 3 to the power of 3 is equal to 54. So A into 27 is equal to 54. A is equal to 54 divided by 27. A is equal to 2 I get. So I got to know what is A as well as what is R. So I can write required GP is given by the terms A, AR, AR square, AR cube, so on, because this is the general form of GP. So now A is what, children? 2, then 2 into 3, then 2 into 3 square, then 2 into 3 cube, so on, because R is equal to 3. So I'll get it as 2, then 6, then 18, then 54, so on. Clear, children? So this is our required GP. Now let us see the next question. The next question says that the second term of geometric progression is 6. In the sense T2 is equal to 6. T2 can be written as AR is equal to 6. I'm just calling this as equation 1. Later, fifth term is 9 times of its third term. So it is clearly given to you the fifth term is 9 times of its third term. So T5 is equal to 9 into T3. T5 is AR to the power of 4 is equal to 9 into AR to the power of 2. So here A can be directly cancelled. R to the power of 4 by R square is equal to 9. Then R square is equal to 9. R is equal to plus or minus square root of 9. Then I can say R is equal to plus or minus 3. So you're asked to find out GP and you're asked to find out only each and every term is a positive. So here I need to take, so if R is equal to plus 3, if I take R is equal to minus 3, then I would get some of the terms of the GP as minus as well. So I will consider R is equal to plus 3. So substitute R in any of the equations. I'll just consider equation 1. So A into 3 is equal to 6. A is equal to 6 by 3, 2. So I got A as 2 and R as 3. So A and R are sufficient for me to find out the GP. So I can write down required GP is A, AR, then AR square, so on. So A is what here? 2, then 2 into 3, 2 into 3 square, so on. So 2, then 6, then 18. Okay, so these are the required terms of the GP. Is it clear, children? Yes. Now let us consider one more question over here. Find the third term of GP from the end. Okay, from the end you are asked to find out. So now you are not going in the forward direction, children, you are coming in the backward direction. Clear, children? So that time 162 is going to be the first term of the GP since you are coming from the end. So A is equal to 162. So R you are supposed to find out. Here it is already given to you, it is GP. So R is equal to 2 by 9 divided by 2 by 3. Suppose if you are going in the forward direction, then you would have divided 2 by 3 by 2 by 9. Since you are coming in the forward direction, backward direction, you should write 2 by 9 divided by 2 by 3. So I can write this one as 2 by 9 multiplied by 3 by 2. So 2 will get cancelled. R will be equal to 1 by 3. So I know what is A and I know what is R. So what you are supposed to find out? You are supposed to find out the third term from the end. So now third term from the end. Okay, I can write third term from the end. From the end is equal to, from the end is equal to AR 3 minus 1. So AR square. So A is what, children? 162. R is what, children? 1 by 3 the whole square. So I can write T3 from the end is equal to 162 into 1 by 9. So when I divide this by 9, 162 divided by 9 will give me what, children? 18. So that is nothing but the third term from the end. Clear, children? Okay. So now let me consider some of the properties of GP. So what are the different properties of GP we are going to deal with? So be very careful over here. So now the first property says the ratio between consecutive terms of the GP is always same. So that is nothing but what, children? R is equal to T2 by T1 I wrote. Okay, or this is equal to T3 by T2 I wrote. Ratio between each term, okay, will be same. So next is if A, B, C are in GP, then B square equal to AC. Why, you please tell me? If A, comma B, comma C are in GP, then I would write it as B by A. What I get it as common ratio. It will be same as C by B. So when I consider this, then I cross multiply, then I would get this one as B square is equal to AC. B square is equal to AC. Next one is, look at this. If each term of a GP is multiplied or divided by a same non-zero number, the resulting number is also, series is also GP. Suppose if I consider a GP 2, 6, 18. If I multiply this numbers by 2, okay, then I would get this one as a 4, 12, then 36. So this also forms a GP. Clear? If I divide, say for example, if I divide this by 2, each and every term I am dividing it by 2, then what I would get over here is 1, then 3, then 9. So over here, this also is going to be GP. Later, the series obtained by taking the reciprocals of the terms of a GP is also a GP. So in the sense of, I have a GP, for example, 6, 24, 96, 394. If I take 1 by 6, 1 by 24, 1 by 96, then also it will be a GP. How it is? Say, for example, here it's already given to you a GP. Now let me find out T2 by T1 over here. So it will be like 1 by 24 divided by 1 by 6. That is going to be 1 by 24 multiplied by 6 by 1. So that is going to be 1 by 4. See, I am getting common ratio as 1 by 4. Suppose if I take T3 by T2, then I would write this one as 1 by 96 divided by 1 by 24. Then this would be 1 by 96 multiplied by 24 by 1. That is equal to 1 by 4 itself. So since the common ratio is same, so I can say the reciprocal of given GP is also a GP. So each term is raised to the same non-zero number. The resulting series is also a GP. So look at this. I am having a GP over here 2, 8, 32. what I do, I'll square on both side. I'll square on both side. Clear, children? So when I'm squaring on both side, you must understand that 2 square is what? It is 4. 8 square is what? 64. Then 32 square is a 1024. So this also will remain as a GP. Clear, children? This is also one of the property. Now next property says that if the corresponding terms of two different GPs are multiplied together, the resulting series also is a GP. So now I'll show you a simple example over here. I'll just take one GP over here, 2, then 6, 18. I'll take one more GP, 1 multiplied by 4 multiplied by 16. Clear? Here the common ratio is what? 3. Here the common ratio is 4. Now what the property says, the corresponding terms of two different GPs are multiplied together, the resulting series so obtained is also a GP. When I multiply this into this, I'll get it as 2. Okay, and when I multiply this into this, 6 into 4, that is 24. I'll get it as 20. Yes, children. Now we are going to study a very new concept, that is sum of n terms of GP. So what do you mean by sum of n terms? You know the general form of GP, which is given by general form of GP is given by AR square, AR to the power of 3, so on till AR to the power of n minus 1. Okay, so sum of n terms in the sense of what I'm going to get when I add all these terms of the given GP. So here 3 cases arise. Okay, so one case, the case number 1, the first case would be if R is equal to 1. If R is equal to 1, then I can say the sum of n terms of the given GP is given by A into n. Why it is so? Because if R is equal to 1, each term would be A, like that it is going to be n times. Right? So, sum of n terms would be Sn is equal to A into n. Clear, children? So, now case number 2. Case number 2. If modulus of R is smaller than 1. You must know what you mean by modulus of R, children. So modulus of 3, if I am supposed to find out, I am just showing you an example. It is going to be 3. Modulus of minus 3, if I am going to find out, that is also going to be 3 only. So modulus of 1 by 2, if I am going to find out, that is going to be 1 by 2. Modulus of 1 minus 1 by 2, if I am going to find out, that is also plus 1 by 2 itself. So that is the meaning of a modulus of a given value. Clear, children? So now if modulus of R is less than 1, then Sn will be given by the formula A into 1 minus R to the power of n by 1 minus R. This is going to be the formula if modulus of R is lesser than 1. So now case number 3. What if modulus of R is greater than 1? Then Sn will be given by the formula A into R to the power of n minus 1 by R minus 1. So these are the formulas to find out the sum of n terms of the given GP. Suppose if I know the last term of the GP, that is nth term of the GP, I can use one more formula. Sn is equal to LR minus A divided by R minus 1. That is if modulus of R is greater than 1, and also I can use the formula A minus LR by 1 minus R if modulus of R is smaller than 1. So these are the key formulas what actually I am going to use the find out the sum of n terms of the given GP. Now I'll give you some examples how actually we are going to use these formulas to find out the sum of n terms. Now let me take the first question, that is question number 1 of the exercise. Find the GP, find the sum of GP 1, 3, 9, 27. So here you must know the first term is A itself. So A is equal to, what is A, children? it is 1. Then here second term is equal to 3. So I'm supposed to find out the common ratio, that is T2 by T1. I'll find out. T2 is nothing but 3, T1 is nothing but the A, so that is equal to 3 I get. So modulus of R is equal to modulus of 3, that is equal to 3, which is greater than 1. So if R is greater than 1, then Sn is equal to A into R to the power of n minus 1 by R minus 1. So now what is n over here? I'm supposed to find out the sum till 12 terms. I'm supposed to find out the sum till 12 terms. So now I'll just substitute the values. A is 1, then R to the power of n, that is 3 to the power of 12 minus 1 divided by 3 minus 1. So R is 3, then n is 12. So later I can write this one as 3 to the power of 12 is 5, 3, 1, 4, 4, 1 minus 1 divided by 2. 3 minus 1 is 2. Clear, children? So now that is going to be like 5, 3, 4, 4, 0 divided by 2. So when I simplify that, I would get this one as 2, 6, 5, 7, 2, 0 when I divide it. So this is going to be the sum of 12 terms of the given GP. Clear, children? You must know how actually I'm using the formula. Now let me take one more example. See, you are asked to find out the sum of the given GP to 9 terms. So here, what is the first term? First term is same as T1, children. You must understand that A is equal to 1. Then the second term, that is T2, is equal to minus 1 by 2. Clear? So I'm supposed to find out R over here. R is equal to T2 by T1, that is minus 1 by 2 divided by 1. So that is equal to minus 1 by 2 itself. R is equal to minus 1 by 2. So now modulus of R is equal to modulus of 1 by 2. So that is equal to 1 by 2, which is smaller than 1. So now I know what is the formula to be used when R, modulus of R is smaller than 1. So I use the formula Sn is equal to A into 1 minus R to the power of n by 1 minus R. Clear, children? So now I do the substitution. A is 1 itself, then later it is 1 minus R is how much? Whenever I am substituting R in the formula, keep in mind, don't substitute it as modulus of R. Whatever value of R you have got when you are dividing T2 by T1, the value of that R to be substituted over here. So now I can write this one as minus of 1 by 2 till how many terms? 9 terms. So n is equal to 9. N is equal to 9 divided by 1 minus R. 1 minus of minus 1 by 2. Clear, children? I hope so the substitution is clear. So now what can I write? I can write this one as a 1. I can just ignore it. Then I can write 1 minus of minus. It is going to be 1 by 2 to the power of 9. Right? Because whole to the power of 9, 1 to the power of 9 is 1 itself. So now this is going to be 1 plus 1 by 2. So that is going to be 1. Here you must understand, minus of minus 1 by 2 to the power of 9 is 512. Clear, children? So divided by, I'll get this one as 3 by 2. So later I can write this one as 1 plus 1 by 512 divided by 3 by 2. So later when I take the LCM and simplify, if this is taken to the numerator, this becomes 2 by 3 into 512 plus 1 by 512. So that is going to be 2 by 3 into 513 divided by 512. Clear, children? So when I simplify this, whenever it is possible, you simplify it if it is possible. See, 2 1s are 2 over here, 2 2s are 4, 2 5s are 2 6s are. So 3 1s are, then 3 1s are 3, 3 7s are 3 1s are. So I'll get this one as 171 by 256. So I can write that sum of 9 terms of the given GP is 171 by 256. Clear, children? I hope so it is clear to you. Now let us go ahead with the next question. See, how many terms of the geometric progression 1, 4, 16, 64 must be added to get the sum equal to 5461. So here, what is the data you must understand, children? So A is given to you, A is equal to 1, then T2 is equal to 4. I am going to find out R. R is how much? That is T2 by T1. So that is 4 by 1 is equal to 4 itself. And you are given with the sum of the n terms. 5461. So your job is to find out how many terms to be added from this given GP to get this sum. That is your question. Clear, children? So now here I'll find out the modulus of R, that is modulus of 4 is equal to 4, which is greater than 1. So I need to use the formula Sn is equal to A into R to the power of n minus 1 by R minus 1. Later, I do the substitution. Sn is known to you. That is 5461 is equal to A. A is 1. Later, I can write this one as a 4 to the power of n, because I know R is 4 minus 1 divided by R minus 1, in the sense 4 minus 1. Clear, children? So now I can write this one as 5461 multiplied by 3 is equal to 4 to the power of n minus 1. Clear, children? Right. So why did I multiply by 3? This 3 goes over there. Right. So when I multiply it by 3, what I get? I get it as 16383 plus 1 is equal to 4 to the power of n. Why plus 1? This minus 1 is taken to the other side. Clear? So then I would get this one as 16,384 is equal to 4 to the power of n. So now what you can do? You can do the prime factorization. In fact, I don't want to call it as prime factorization because I want this number to be expressed as 4 to the power of something. So directly I take it as 4 over here. So 4 is not a prime number. So I don't want to call it as prime factorization. I'm just dividing the 16,384 by 4. So here I would get this one as 4096. Then again divide by 4. 1026. Again you divide it by 4. Then I get this one as 256 divided by 4. 6 za 4 za. Okay. 64 I get. Then again you divide it by 4. Then 16 I would get. So 4 4 za 4 1 za. So 1, 2, 3, 4, 5, 6, 7. I can express it as 4 to the power of 7 is equal to 4 to the power of n. Since the bases are equal, so equate the powers. So I can write n is equal to 7. So required number of terms which are to be taken to get the sum of 5461 is 7. Is it clear, children? I hope so. This is clear to you. Now let us move to the next question. The next question says that the fourth and the seventh term of the GP are 1 by 27 and 1 by 729 respectively. Find the sum of n terms of this GP. So over here T4 is given to you, children. See, fourth term of the GP is 1 by 27. T4 in the sense AR to the power of 3 is equal to 1 by 27. I just call this as equation 1. So later, what is given to you? It is given to you that a seventh term is 1 by 729. So T7 is equal to 1 by 729. T7 in the sense AR to the power of 6. It is 1 by 729. I just call this as equation 2. So now what I do? I will divide equation 2 by equation 1. Equation 2 by equation 1, if I do, then I would get this one as AR to the power of 6 divided by AR to the power of 3 is equal to 1 by 729 divided by 1 by 27. So AA would get cancelled over here. Here I would get this as R cube is equal to 1 by 729 into 27 by 1. So r cube is going to be 1 by 27 because 729 is square of 27. 27 ones are 27, 27s are, I get it. So r cube is equal to, I can write this one as 1 by 3 the whole cube. Since the powers are equal, I can equate the bases. R is equal to 1 by 3. Clear, children? So now what I do the substitution of R in any one of the equations to find the value of A. Right. So substitute R in equation, any one of the equation, whichever is easy. Equation 1. So A into 1 by 3 to the power of 3 is equal to 1 by 27. So A into 1 by 27 is equal to 1 by 27. That implies A is equal to 1. So I got what is R and also I got what is A. Clear, children? So now what you're asked to find out, find the sum of n terms. So next I need to find out the sum of n terms. So which formula to be used? That is going to be decided on by finding out the modulus of R. Modulus of R is equal to modulus of 1 by 3, which is equal to 1 by 3, which is smaller than 1. You need to remember, children, all proper fractions are lesser than 1 and all the improper fractions are more than 1. Once you get here proper fraction, you can aramse decide that it is lesser than 1. Clear, children? So now I am going to use the formula Sn is equal to A into 1 minus R to the power of n by 1 minus R. Clear, children? So that is going to be 1 into 1 minus of what is R? I told you this R to be taken. Modulus of R, don't substitute that one. What is actual R? That should be substituted. If it is plus, plus or minus, whatever it is. So I can write here 1 by 3 to the power of n later by 1 minus 1 by 3. Clear, children? So now what I'm going to get here is 1 minus 1 by 3 to the power of n. So that one divided by what I get over here is 3 minus 1, that is 2 by 3. So I can write the final answer as Sn is equal to, when I take this to the numerator, it becomes 3 by 2, then 1 minus 1 by 3 to the power of n. Now let us see the next question. Before, when I multiply 18 with 16, children, okay, I'll get it as a 288. So this also is going to be a GP. You can check the common ratio here. Common ratio will be 24 by 2, that is 12. Okay, 288, even if you divide 288 by 24, you also get it as 12. So since the common ratio remains same, this also is going to be a GP. Clear, children? So the other property says that in the same way, if the terms of GP are divided by corresponding terms of the other GP, then the resulting series so obtained is also a GP. So here I'll take the same example. Here I have multiplied. Later I will divide it and show it to you. So I'll consider the same GP 2, 6, 18 and 1, 4 and 16. What I do, I divide one of the GP by other GP. Say for example, I am dividing first GP by second GP. So I'll get it as 2 by 1, then 6 by 4, then 18 by 16. So what I get is 2, then 3 by 2, then I can write 9 by 8. Clear, children? So this also is going to be a GP. How can I prove it is a GP or not? With example, I'll show you, children. Here I am finding out the common ratio, right? So if I find out the common ratio for this one, that is 3 by 2 divided by 2 if I do. Okay, so 3 by 2 into 1 by 2. So I'll get it as 3 by 4 is the common ratio. Now if I divide T3 by T2, 9 by 8 divided by 3 by 2 if I do. Okay, so then I would write this one as 9 by 8 multiplied by 2 by 3. So 2 ones are 2 fours are 3 ones are 3 threes are. So what I get, children? I get it as 3 by 4 again. See, since the common ratio is remaining same, I can again say that this, okay, series is also a GP. This is also a GP. Now see the next question, children. In the next question, it is given to you that in a GP, the ratio between the sum of first three terms, so S3 is given to you, first three terms, and that of first six terms, S3 is to S6 is given to you. That is 125 is to 152. Okay, children. So what is S3? You know that the sum of n terms of GP is given by a formula. So here n is 3. So I can write this one as a into r to the power of 3 minus 1 by r minus 1 divided by a into r to the power of 6 minus 1 by r minus 1. This is sum of 3 terms and this is going to be the sum of 6 terms. This is going to be 125 by 152. So a into r to the power of 3 minus 1 by r minus 1 multiplied by r minus 1 a into r to the power of 6 minus 1 is equal to 125 by 152. So you can ask, sir, why have you taken, how do you know that r is greater than 1 over here? See, ratio of sum of first three terms and first six terms. So the denominator is greater, in the sense what? The GP is increasing. Clear, children? So I have taken r is greater over here. So now r minus 1 will get cancelled, then a also will get cancelled. I'll be left with r to the power of 3 minus 1 by r to the power of 6 minus 1 is equal to 125 by 152. So later I can write this one as r to the power of 3 minus 1 by r to the power of 3 square minus 1 square is equal to 125 by 152. So r to the power of 3 minus 1 by here I can write it looks like a square minus b square. So r to the power of 3 minus 1 and r to the power of 3 plus 1 is equal to 125 by 152. So r to the power of 3 minus 1 and r to the power of 3 minus 1 will get cancelled. I'll be left with 1 by r to the power of 3 plus 1 is equal to 125 by 152. I'll be left with. Clear, children? So later what can I do? Here I can write this one as be very careful here. So when I take the reciprocal, r to the power of 3 plus 1 is equal to 152 by 125. So r to the power of 3 is equal to 152 by 125 minus of 1, because this plus 1 is taken to the other side. So r to the power of 3 is equal to 152 minus of 125 by 125. So I'll get r to the power of 3 is equal to 27 by 125. So r is equal to cube root of 27 by 125. So r is equal to 3 by 5. So common ratio I am getting it as 3 by 5. Yes, children. Now let's see the next question. In the next question, find how many terms of the GP so and so must be added to get a sum equal to 55 by 72. So here GP is given to you. So I can write that A is equal to 2 by 9. Then T2 is equal to minus 1 by 3. So A is nothing but our T1. So to get the common ratio, what should I do? T2 divided by T1. So that is nothing but minus 1 by 3 divided by 2 by 9. So that is equal to minus 1 by 3 multiplied by 9 by 2. So 3 ones are 3 3s are minus 3 by 2. That is nothing but the common ratio. So here I need to find out the modulus of a common ratio, that is modulus of minus 3 by 2. So that is going to be 3 by 2. That is nothing but 1 by 2, which is greater than 1. So now Sn is given to you. So Sn is equal to, it is given to you, Sn is equal to 55 by 72. So now children, which formula of Sn should be used? See here, modulus of R is greater than 1. So I am supposed to use A into R to the power of n minus 1 by R minus 1 is equal to, by R minus 1 is equal to 55 by 72. Now I'll do the substitution. A is how much? 2 by 9. 2 by 9. Then r to the power of r is how much? Minus 3 by 2 to the power of n minus 1 divided by r, that is minus 3 by 2 minus 1 is equal to 55 by 72. So now I'll keep this as it is, that is minus 3 by 2 to the power of n minus 1. Here I'll be having it as a minus 5 by 2 is equal to 55 by 72. So later 2 by 9, I'll again keep this step as it is, minus 3 by 2 to the power of n minus 1 is equal to 55 divided by 72. So this is taken to the numerator on the other side, multiplied by 5 by 2 with a minus sign. So now I can write minus 3 by 2 to the power of n minus 1 is equal to 55 by 72 multiplied by minus 5 by 2 again multiplied by 9 by 2, because this 2 by 9 is taken to the other side. So when I simplify this, I will get this one. Wherever it is possible to cancel, you can cancel, children. For example, 9 ones are 9 eights are. So then 55 into 5, 5 5s are 25, then 27, then here I'll get it as 32 with a minus sign, because this is minus over here. So this is equal to what? Minus 3 by 2 to the power of n. So in this step only, I'll take this minus 1 to the other side, it becomes plus 1. So now if you observe carefully, minus 275 by 32 plus of 32 I can write. Clear, children? So now I can write this one as a minus of 243 by 32. Here minus 3 by 2 to the power of n. So minus 3 by 2 to the power of n is equal to, here it is minus 3 by 2 to the power of 5, because 2 to the power of 5 is equal to 32 and 3 to the power of 5 is equal to 243. So I can write this one. Since the bases are equal, I can equate the powers. So n is equal to 5. Clear, children? So I can say required number of terms is equal to 5. I hope so this is clear. So now let's move to the next question. In the next question, the sum of 3 terms of GP. See, wherever 3 terms are involved, children, what you are supposed to take, let the 3 terms be. Let the 3 terms be A by R, A and AR. Now what is given? Sum of 3 terms of GP is 39 by 10 and their product is 1. So now the product of the terms is equal to 1, in the sense A by R into A into AR is equal to 1. So R will get cancelled. I'll be left with the A cube is equal to 1. So A is equal to cube root of 1, that is A itself. Now second part of the question. The sum of the 3 terms is 39 by 10. So now what I'm supposed to do? Sum of the 3 terms, in the sense A by R plus A plus of AR is equal to 39 by 10. So I have got to know that A is equal to 1. So I can write this one as 1 by R plus 1 plus R is equal to 39 by 10. So when I take LCM and simplify, I can write this one as R. 1 plus R square is equal to 39 by 10. So when I cross multiply, children, I would get this one as 10 plus 10R plus 10R square is equal to 39R. Now since the highest power is 2, I get a quadratic equation over here. I can write this one as 10R square plus of 10R minus of 39R plus of 10 is equal to 0, because this 39R is taken to the other side. So 10R square minus of 29R plus of 10 is equal to 0. Now this is the quadratic equation. I need to solve this quadratic equation to find the value of r. So I get it as 10r square minus of 25r minus of 4r plus 10 is equal to 0. So here I can take out 5r common, then 2r minus 5 minus of 2 can be taken common, 2r minus 5 equal to 0. So 2r minus 5, then 5r minus 2 is equal to 0. So later 2r minus 5 equal to 0 or 5r minus 2 equal to 0. This is nothing but zero product rule. Clear, children? So I'll get here r is equal to 5 by 2, r is equal to 2 by 5. I can take both of them. So what should I conclude? If a is equal to 1 and r is equal to 5 by 2, the required terms are, see, a by r. So 1 by 5 by 2, then 1 into 5 by 2. So that is going to be 2 by 5, 1, then 5 by 2. Clear, children? So here if a is equal to 1, then r is equal to 2 by 5. Then the required terms are 1 divided by 2 by 5, 1 and 1 multiplied by 2 by 5. So that is nothing but 5 by 2, 1 and 2 by 5. This is the required three terms. These are the required three terms of the GP. So now let me take the next question. In the next question, the first and the last term of GP are 3 and 96. First term is 3, in the sense a is equal to 3. Respectively, if the common ratio is 2, so r is equal to 2. So now last term, in the sense Tn is equal to 96. Means what? A into r to the power of n minus 1 is equal to 96. What you are asked to find out? N, that is the number of terms in the GP. N you are supposed to find out. So 3 into r to the power of n minus 1 is equal to 96. So r to the power of n minus 1 is equal to 96 divided by 3. R to the power of n minus 1 is equal to, I can write this one as 32. So here r is given to you as 2. So I can replace it. 2 to the power of n minus 1 is equal to 2 to the power of 5. 2 to the power of 5 is nothing but 32. So what can I write here? Since the bases are equal, I can write the powers. I can equate the powers. N minus 1 is equal to 5. So I can write n is equal to 6. So this is the answer for the first sub question. So in the second sub question, what is asked over there? Sum of n terms. Okay, sum of n terms. Okay, so Sn is equal to, so here r is what? It is greater than 2. So Sn is equal to a into r to the power of n minus 1 divided by r minus 1. Clear, children? So I'm supposed to substitute the values over here. A is equal to 3. Then r is how much? R is 2. 2 to the power of n terms, that is 6 minus 1 divided by 2 minus 1. So that is equal to 3. Okay, so 2 to the power of 6. 2 to the power of 6 is how much? That is 2 to the power of 3 into 2 to the power of 3. That is 8 into 8. That is equal to 64. So I can write 64 minus 1 divided by 1. Clear, children? So 3 into 63. So that is nothing but 3 into 3 is 9. So 3 into 6 is 18. So Sn is equal to 189 I get. Clear, children? So now let's move to the next question. Next question says that 15, 30, 60, 120 are in GP. They have only told that it is GP. So A is equal to 15. Then AR, that is second term, is equal to 30. So I can write down the common ratio, that is T2 by T1. So that is 30 divided by 15 is equal to 2. Right. So find the nth term of the GP. You are asked to find out the nth term of this GP in terms of n itself. So now the first question, Tn is equal to a into r to the power of n minus 1. A is what? A is 15. 15 into R is how much? 2 to the power of n minus 1. So this is nothing but the nth term of the GP. Then the second sub question, how many terms of the GP will give you the sum as a 945? So over here, sum is given to you. Before that, modulus of R is equal to modulus of 2 is equal to 2, which is greater than 1. So now I'm supposed to use the formula Sn is equal to A into R to the power of n minus 1 by R minus 1. So Sn is equal to 945 is equal to A. A is 15. R to the power of n. Right? How many terms we are supposed to find out n over here? But I am aware of what is A. So I mean what is R. So 2 to the power of n minus 1 divided by 2 minus 1. Clear, children? So 945 divided by 15 is equal to 2 to the power of n minus 1. So it will be 2 minus 1 will be 2 itself. I mean 1 itself. So 1 is taken to the other side. 945 into 1, it will be 945 only. So this 15 is taken to the other side. So now I will cancel it. 15 1s are 15. 15 6s are 90. 15 3s are. So 63 is equal to 2 to the power of n minus 1. So I can write 64 is equal to 2 to the power of n. So 64 is what, children? 2 to the power of 6 is equal to 2 to the power of n. So therefore n is equal to 6. So required number of terms is equal to 6. Is that clear, children? I hope so. It is clear enough. Right. So thank you so much. I hope so. The session is very useful. Do not forget to subscribe my channel. Keep watching my channel and let me know what will be the next topic to be taken in the next video. Thank you so much.